Alright. Welcome back. It is your by the Prokon Geek, and now we are moving on from the foundation to the columns. Alright, guys, what's up? Welcome back. This is the Prokon Geek, and yes, as I told you, we're now moving from the foundations. We did the layouts, we did the foundations, and now it's time for us to do the columns, and in particular the starter columns. So let's not waste too much time and let's just get right into the content of the video today. Okay, so for us to get started, I think we need to understand what we're going to be doing or what we mean by starter columns. So if you remember when we were doing our foundations, and this one in particular is base 1 with column 1. So as you can see, this green bars, the ones that you see that are starting off or jutting off from our base and then proceeding into our column, are what we call the starter bars. And if you remember, the program actually just tells you, it tells you to check the starter bars sizes with the column design. So there's a need for us to design this as well, just to check the sizes. By default, we got a proposition for 16s, 4x16s. As you can see that in section, that means 4x16s at the corners, bar mark 5. But then it is important for us to check if we actually need 16s, and I think we did this when we were actually designing the first base. But now the reason why I want us to do it again is also that we are going to be covering the first. If you see what I have right now on the screen, this is a representation of how I want to detail my columns, or want my steel to actually look like when it's on the site. So obviously we're going to start off with our cage, or the bars that we need for our foundation. As you can see, this is on the green, or if you can follow my cursor, then obviously these dots represent the bars when we cut them through the section. So the first green bars that you see starting off from the foundation and into the column are going to be the starters. That is what we're going to design. But at the same time, we're going to design these bars that you see, which are represented in cyan or blue, whatever you want to call it. So these are also, I'll be terming them the starter bars. So what happens is, obviously you have the starters that start from the foundation, and they left with these starter bars, or the column starters, or which go all the way now from the ground. In these ones in particular, will be going all the way above the ground floor to a height of about 2 meters above the ground floor, because when they're cast on site, concrete is best cast in intervals of 2 meters, 2 meters, 2 meters. So the best thing is, obviously they're going to cast 1.5 up to the ground level, then they leave the bars exposed, and then once they're now casting the other stage, they're going to go 2 meters. But then at the same time, they will then provide these green bars, which will be lapping these blue bars, and these ones will also go all the way through the slab and the beam. That's why they are kinked, as you can see it where my mouse is playing around. And then they lap with those other blue bars, which will finish off with shape code 37 at the top of the column. So we want our column to terminate before it reaches the eaves beam. The eaves beam may be independent, but it will be resting on the columns. So what we are thinking of doing right now is just to design the green bars that you see, which are the actual starters, and also just verify the length or the size of the bars that we are going to need for the blues. These bars that you see, the first column bars, these are actually what I'll term them are the starter bars from the base all the way up to the ground floor. So what we will be doing as well, the best thing for us to do is we're going to be designing from D plus 1500. That is what we're going to do, and then we'll also move, if we have time, to design as well for the 2800 portion that is above the ground floor, but including its lap portion, which goes above the top of concrete of the slab. So that is now what we're going to be doing. So let's just do that and not waste too much time, and also help you understand the process of designing now. So what we're doing is we're now moving on to the rectangular module, and we see how we take it from there. Alright, so to kickstart things, what we need to do is we need to have the rectangular column design module open. Then we also need our column takedowns to be open, or wherever you did your calculations. And then you also need to have your base open. So the first thing we're going to do is just go to our rectangular column design module. The first thing you need to enter H or B. So as a rule of thumb, all you have to remember is that H is the bigger side or the longer side. So this is going to be 300. and then this is going to be 230 because our columns are 230 by 300 or 300 by 230, whatever you want to design it as. But in this case, it'll be 300 by 230 column. And then delta prime, which is the effective depth of steel in the x direction. So we're going to assume cover of 30, and then we're going to assume lengths of what do we call this, 40. So that would 10 millimeters. So that will be 30 plus 10, which gives us 40. And then we're going to assume we need y16 bars, so half of that is 48. So we are going to key 8, so 8 plus 40, we get 48. So we are going to key in 48, so 48 for in the y direction as well. And then for the length of the column, what are we going to do? Obviously, like I said, we want to design for the starters as well, but then we also want to design for up to the ground floor and then all the way to the. So the best thing that I decided is I checked the length, and from the top of the base to where we want to have our last lap when it comes to the bars. In this case, we could consider this as one column. So because what I've just did by detailing these bars or separating them is that we have the green, blue, and the green bars as well, is just to make life easier on site when they're casting their columns. You can actually just design this because the minimum steel length that you get is 6 meters. Then these reinforcement bars come in lengths of 6, 13, and I'm not sure what the other sizes are, but the minimum is 6. So you see 5.125 is not that much of a big deal, so you can actually key in this. So that is what we're going to do. We're going to design for the 5-meter section, and then we're going to separate the bars when we are detailing, which will be another video which we will look at. So in this case, the length of the column, I am just going to put 5125. It's actually supposed to be point because this one is in meters. Then for the columns, the one that I want is 40. If you remember my general notes, the best we can use is 40. So we're going to design for grade 40 concrete. Then FY for the steel, we need high yield steel, so we're going to go with 460. Then comes the question, braced versus unbraced. Are our columns braced or they are not braced? In our case, our columns are not braced because some people don't know the difference between a braced column and an unbraced column. So the difference is a column is considered not to be braced or is considered to be braced if in any given plan there is stability provided that is against the movement that will be caused by lateral loads, either by bracings or by walls. So it's either you have walls when you're dealing with double story, 3 stories, 4 stories, actual brick walls, load bearing walls will brace your columns. But when it comes to 5 story, 6 story, 10 elevations as you go on and on, that's when you start needing shear walls and lift shafts to brace your columns. But in our case, we don't have any lateral bracings, so we are not bracing them bilaterally, but we are bracing them through the use of walls. So some people may be asking me, what are bracings when it comes to columns? So yes, I just go get it for there. And so this is what they call bracing. It's just a member which goes laterally or diagonally so as to hold your columns, so as to prevent lateral movements, as you can see in that picture. So usually this is employed for steel structures. That's where you mostly see, as you can see, most of these drawings, it's steel where you can see that it's clear exactly. For example, in this, you can actually see you have a steel which is an angle, whatever member it is, and it's bracing this. But in concrete structures, it's also common. As you can see, there you have a concrete structure which is braced laterally by the concrete, and then also there you have your columns being braced by other concrete members diagonally. So this is what they mean by braced columns. So if you do not have bracings, you need walls to brace your columns. So in our case, since we have walls, if you remember from the architecture, unfortunately I do not have it open, so we don't want to waste time. So in our case, we can tick braced in the X and braced in the Y because it's braced in both the directions. Then the next thing is the end conditions. We are designing or assuming our columns are pinned. That means our columns cannot transmit any moments to the ground or throughout the entire structure, right? Because we are bracing them using the walls That's the other thing as well. When your columns are not meant to transmit any moments, they need to be braced. So in our case, we are bracing them so we don't need them to transmit any moments. So they are pinned at the bottom and pinned at the top. Because why we're saying pinned at the top is because there's going to be continuity, as it's going to be it will be joined to the column that is at the top level. So it's going to be pinned. Then the effective length factors, these are calculated automatically as you change the end conditions. As you can see, as you change the end conditions, these values change automatically. Then it tells you there are no errors. You can proceed to enter your loads. So in the load case, obviously you're always going to put the worst case. It's going to be the dead load plus the live load. If you want to save time, if you want, you can put as many cases, but we're just going to go with the worst case scenario. So in this case now, P, when it comes to columns, this is the unaffected total load. In our case, this is going to be, no, it is the affected, please forgive me, it is the affected, is the maximum affected load including the self weight of the column. In our case, it's going to be 672 because we're dealing with a portion that is going to the top of the base, so we need to deliver the maximum load. Once we get to the second floor, or no, I mean the first floor, we will be able to have, or we will have the liberty to remove the slab component and also one of the column components, such that we will be putting 224. But as for now, we do not have that liberty. So what we're going to do is we're going to design it using, let me go where are the columns, let me just put back 2. We're going to design it using 672.653. all right, so that is what we're going to put. 670, let me check, 72.653, 72.653. And now once you have done this, since we don't have any moment in the X and the Y at the top or the bottom, we're good. The next thing is to click on design and let's see what this means. Alright, so now that we have clicked design, we have the results. Prokon has designed the column for us, and now it's time for us to look at the results and interpret them. So as a rule of thumb with Prokon, as long as there's nothing in red, you are good to go. Your structure is safe and your section is good. If it was a smaller section as compared to the load that you entered, it would highlight it in red for you with ASC. But let's go through the results. So obviously it's going to give you the graphs, give you the moments that are carrying, gives you the results in the X and in the Y axis. Then the next thing, the design results are given at the bottom right corner, as you can see where my mouse is. Let me just click so that you see it. Now the first row that you have obviously is just going to be the load that you have entered at the top, middle and bottom. It assumes it's the same throughout the entire column. Then obviously the next thing is if you had put any moment, additional moment at the top, additional moment at the top as well, then MX and MY at the bottom, it was going to be able to see what this is where if you had any moments. Let's just go back to the input. If you had anything here, let me just put 260 so that you can visualize. We can't visualize because now we need to change them to fixed, but it's okay. If we had put 60 and we had made sure that they were fixed at the top, it was going to appear on any one of those rows where we would have put that value. Now it also calculates the minimum moment that would arise in any case if we needed our column to transmit it to the foundation, but that is going to be cancelled out since we designed our columns as pinned columns. Then the next thing that it does, it tells you the design axis, the main design axis, and by default it's always going to be the y axis because that is where H is. So it's the main design axis is always going to be the longer side, so it's always going to be y. Then the next thing is going to be ASC. This is the area, right? The area of steel that is required to satisfy your design at the top, at the middle, and at the bottom. And obviously, as you can see, at the middle is where we need the most steel. So that is what it is going to use to distribute throughout the entire structure. That is in the design axis. But at the same time, it then computes the area of the steel as compared to the area of the concrete to see if you're not going beyond the percentages that are stipulated for reinforcement. So you know the minimum reinforcement any concrete section needs is 0.13%. That is if you're using high yield steel, and the maximum value I'm sure is between 4% and 6%. I will need to check with the code, but just try to deal with 4% for minimum for the maximum and 0.13 for the minimum. So as you can see, 0.40, 0.66 and 0.40 are okay. They are in between the range, so you are safe. Then the next thing, it also computes the amount of steel you need now in the x-axis, and as you can see, it's 277, 277 and 277 from the top all the way to the bottom, so you're okay as well. And then if you had multiple cases, this is where it would highlight which case you would need and which you are viewing right now. And if you had a different case, all you have to do is to put next. So this one we can visualize. All you can do is just put load case 2 and we'll say funny. All right, and then you go back to design. Oh, range check error. You definitely do need to put something. That's the problem. Okay, let me put 20. See if we can visualize. Right, next it would put a different load case. In this case, if you see design results for load case 2, which is termed funny, and then it would show you you could next just go through which one is what is what, just showing you the differences in each. But now, since we do not need it, the best thing is just to delete it. But then the beauty, as you can see, no matter how many load cases you have, it always shows you the critical load case first. So that is why when I was entering my loads, I just dealt with the critical load case, and that is what we have. So then it gives you the maximum steel that you need in the x-axis, and it is shown there. And that's all it is when you're looking at the design tab. The next two tabs are the design charts for the x-axis and the design chart for the y-axis. This is basically the charts Prokon was using to come up with the steel that you would need to put into your columns to reinforce against the loads that you provided. So they're not that too important to you, but they're important for the program. And also if you just want to get a hang of what the program was doing, especially if you're a beginner, they're quite important. But for you as a beginner, they're not that important. Then the next thing is the calc sheets. We already know what the calc sheets are. They just give you a history so that you can print out your results, send them to somebody for verification, or just double check. They allow you to give you a history of what happened, and also for you to see what you entered and to see if it makes sense when you start going through it again. Like we did in the previous video, we went through our things and we found some mistakes and we amended those mistakes. So it's the same thing. I will obviously have this and I'll go through it so that if I see any mistakes, I'll just iron them out. But if you don't, we just proceed. Then last but not least, the next thing we get is the bending schedule. Alright, so we have come to the last part and we're looking at the bending schedule. So the bending schedule is quite similar to the bending schedule tab you see when you're designing your bases. So same thing, the first thing you change is the schedule file name. In our case, we designed column 1, so what we're going to do is let's put it as col01. Then the diameter of the column bars, this is what Prokon is suggesting for you. What you need to do is put 4/16, right? It's saying the diameter of the corner bars, because by default any rectangular column has to have 4 bars. There's the minimum, and if it's a circular column it's 6 bars, but then we will look at that in another video for another building that has circular columns. The other thing it does is it provides you with number of middle bars in the XX, number of middle bars in the Y. So in this case it's saying you don't need any middle bars. Let me just show you what these middle bars are. So I'm going to put 1 and I want you to look what happens over at the section. So once you put 1, and then you come out, as you can see, a bar has been added at the middle in the XX direction. And then if you also go to the X and the Y, as you can see, we have added another bar, But I want you to see something. As you were adding these bars, let me just put 0 and 0. The entered value of steel that you had is 804, and the one that you entered for the y-axis is 804. But the moment you increase the number of bars as well, the amount of reinforcement you're entering is also increasing. As you can see there, it's now 1030 and 1030. So the most important thing when it comes to this is just to make sure that the reinforcement that you put is always above the required and the nominal. So in our case, let me just put 8. Once you put 8, as you can see, it doesn't work. It does not work. You're getting less than what is required, so your design would fail. So the best thing is sometimes Prokon gives you the best design. You want to stick to it. In this case, you don't need to enter any extra bars. They are not necessary. It's an over design. So the other thing that we want to do as well, let's just go to detailing, our detailing codes. Then the next thing that I want you to do is just to have a feel of how you detail these columns. So detailing the columns, we are going there, we are going there. So this is what I wanted to show you. The main reinforcement. The longitudinal bars should consist of mild steel or high tensile steel bars of diameter at least 12 millimeters, which is what I wanted to go to. So the minimum size of a bar that you can put in a column is a 12. In our case, if we put 12s like this, we fail. Why? Because in the YY we are failing to provide enough steel. So maybe we would pass now when we put middle bars. As you can now see, 6 bars in our column. But looking at it, it's better for us to put 4 bars only. The reason why is because once you put these extra bars in the middle, you start to need what we call clips. As you can see this, as you look at the bottom, obviously when you have just 4 bars, let me just show you when you just have 4 bars. When you have 4 bars, you only have this link. And remember, this R8C that you see, these are tie links. These are only 3 links which will be put at the top where the column kinks, so as to fix them when the next column is coming up. But the moment you add an extra bar, now you are going to need clips. So these clips will be coming all the way from 0 all the way to 5125. As you can see now, this extra bar mark is C. It has been added. You're going to need 26 more bars. So you see that you are using more unnecessary steel. So the best thing is just to make sure that you have your 4 bars and you don't need the extra clips. You see, you just have your links, then double set of links at the kink, and your 3 ties. Instead of having 26 pairs of links and then having 26 pairs of clips, all because you wanted to use 12 millimeter diameter bars. So those are some of the things you need to be thinking about when you are designing your things. Sometimes it's best to just use 16ths because you save on steel, instead of, because you don't now need 26 clips which you don't need them for anything. That is just a waste of steel, right? It's better to just buy 16s. They don't cost that much more than your 12s, so it's better to just use 4 bars instead of using 6 bars. So yes, that is it. The next thing that you want to do is, obviously, you can change the size of your links or the type of the links. If you want, it's an R8, that's mild steel. If you want Y10, high tensile steel, it's good. It's up to you. We will talk about the spacing when we start actually detailing these bars. Then the link types, it shows you what type of links do you want to use, 1, 2, 3 or 4. You can choose, but by default it's 3, so that whenever you add middle bars, you will have predominantly links around middle bars, only clips around middle bars, right? But by default, as long as you add a middle bar, you will have clips. Then the lap length factor, I told you in compression it's 40, tension it's 50, so 45 is okay because the column is mostly under compression, so that is what you want to do. Then the cover on the links is always 30. It's not always 30, it depends on what you're going to use, so just change it appropriately, but we're using mild exposure, so it's 30. And then You can change it down here whether you want a continuous column. If you don't make a continuous column, this is what we're going to use when we are now terminating the column at the very end, but our column is continuous. This is what you need. And then double links or add the kink or not. Yes, provide double links. And then whether they're going to be starters, if you wanted to design the starters only, you were obviously going to say these are starters only, and then you would have them as shape with 37. But we're just not going to take that. All we wanted to note from this, as we are going to save it, is to see that what size bars we need for the corners. So if you want, you can go ahead, generate the schedule, click OK. Alright, that's okay. You've generated your schedule, and then you can now say file save as. So this is saving the bases, but now we move into the columns, and let's just save here. What we're gonna do is we're just gonna call this column. Yeah, we can call it column 1. What else would you want to call it? Let's just call it column 1, and we're good to go. Now we have saved our file. The next thing is we will design for all the other columns that we have, that is column 2, column 3, and column 4. But this time we'll be moving with speed, because now I think you understand where columns come from, the design and everything. And yo, Irie, sorry, now I sound a little bit off color because now it's getting late, it's 8, and now I have time to go. But as usual, stay Irie, stay blessed. I think it's time for me to watch a movie now. So until the next time, subscribe to the channel, like it and share, and I'll see you next time. Bye.